Now, why are we getting this error here when using server-side rendering? Well, in the end, it's coming from the tasks service file, because there in the constructor, I'm reaching out to local storage to load tasks, because I'm using local storage to store tasks. But the problem now is that local storage is a browser-side feature, so it's not available on the server side. And therefore, when Angular tries to run this code on the server, which it does when it tries to pre-render the page, will encounter this error. So what can you do to make it work? Well, one easy and recommended workaround is to use the after next render function. This is a function about which you learned earlier in the course. You can import it from @AngularCore. And this is a function that takes a function as an argument. And this function will then only be executed by Angular after the next component render cycle. Now, of course, here we're still inside of a service, but this service in the end is of course being used from some component in the end in this application. And therefore, of course, components are being rendered by this application. And after next render does not care about which component is being rendered next. It simply allows you to register a function that executes some code that will be executed the next time after all components have been rendered. So the next time Angular is done going through all your components and rendering them, you could say. So the next time it's done rendering that component tree to the DOM. And therefore, this also is a function that will only execute on the client side. Because of course, Angular does also render the components and prepare some HTML code on the server, but they're only rendered to the DOM on the client side, because the DOM only exists on the client side. And it's after that client-side render cycle that this function which you pass to after next render will be executed. And that's why inside of this function you have a safe place for executing any code that must only run in the browser, so that needs access to browser-side features, for example. And now we can simply tell Angular that it's after the next overall component render cycle we want to execute this code. So this is a safe place to execute code that depends on the availability of the browser, so that should not run on the server side. And therefore, with this change made, if you save that and you stop that running server by pressing Ctrl+C, and you then run npm run build again to build the updated Angular project for server-side rendering. If you do that, and you then run that command again to serve that server-side rendered application locally in this case, if you now reload this page or visit some other user, you'll see that now you're no longer getting an error here, because now this local storage code really only runs in the browser, not anywhere else. Now, one problem you might notice here with the current implementation in this specific application here is that if you are on the page of a user, so that you see the tasks of that user, if you load this page, if you visit this path, you get these tasks. But if you then navigate to a different user and come back, you see a different list of tasks. And the reason for that is that after coming back, it's actually the tasks from the local storage that are showing up here. But initially, if you reload this page, it's the server-side rendered tasks list. And that list in the end uses these dummy tasks that are set up here. Because local storage can't be accessed on the server side, we made sure that this code doesn't run there. Now, of course, this code does run on the client side, and this tasks signal is updated with the tasks on the client side therefore. And that's why we see those tasks if we then navigate around at some point. But initially, we don't see those tasks. And the reason for that is that I am updating a signal, but the tasks that are displayed here are in the end loaded with help of a resolver. Remember that we have this resolver here, which reads the signal once and does not set up a subscription to then prepare the tasks for the user. And then those tasks are made available through an input. That's how those tasks are rendered. And on the client side, once the finished page has been received, this resolver does not run again. So we don't fetch the updated tasks there. So for this specific application, we have some code here that actually leads to a bug. Now, to fix this bug, it would probably be best to use a different data source. A data source that also works on the server, like a separate backend to which we send requests with Angular's HTTP client, for example. That would make sure that the code runs on the server and the appropriate data is fetched on the server already, so that we don't have this mismatch between client-side code and server-side code. If you don't want to do that, or you can't do that, it would probably be best to get rid of that resolver and instead load the tasks in the component based on the signal, so that when the signal changes, which it does here once the tasks have been loaded, the component is updated. This would then probably be a better solution. And that's why attached you find an updated project that does switch to that approach and that does not have this bug which you're seeing here. I'm showing this on purpose here though, because these are things and potential problems you have to be aware of when implementing server-side rendering. Because as mentioned before, building server-side rendered apps has certain advantages, but it also has disadvantages, and increased complexity or extra problems you might run into belong to those potential disadvantages, which is why I wanted to show some potential problems here. Now, before we'll take a look at how you could deploy server-side rendered apps, I want to explore the last main option you have when it comes to building Angular applications. And that option is about static site generation, SSG. And in the end, this option is a combination of the two other options, you could say. Because the idea here is that you do have some server-side rendered application, but that Angular routes are also pre-rendered at build time. So that when a user visits a certain page, that page might already exist because it was pre-rendered during the build process, and it doesn't need to be rendered dynamically on the server when the user sends their request. Therefore, that page can be served quicker than if it would be pre-rendered on demand on the server, which is what we have with just server-side rendered apps. There, every page is rendered on demand on the server when a request comes in. With this third option, at least some pages are pre-rendered at build time instead. Now, the browser still receives the finished page, therefore, no matter if it was pre-rendered or if it's a page that was not pre-rendered and that was therefore dynamically rendered on the server. And then, just as before, this application, this page, is in the end hydrated on the client side in the browser and becomes a single page application after it was received by the browser. Now, when using static site generation, you still need a dynamic web server unless you really pre-render all your application pages. But if you have a mixture of some pre-rendered and some dynamically rendered pages, you need a dynamic web server. Now, a potential disadvantage of this approach is that if you pre-render a page that fetches data, that data is of course fetched during the build process and never thereafter. So you might be showing some outdated data on your website until the application is built again and the pages are pre-rendered again. Now, for some data, that might not matter. Some data might not change that often. But of course, depending on which kind of application you're building, you also might be dealing with data that must be as up to date as possible. And in that case, pre-rendering pages that rely on such data is a bad idea. But with that out of the way, let's see how you could add pre-rendering to your Angular application.